So this is a pretty good indication of what you might see on your test. There's going to be at least, well, you know what, there's going to be one explosion, and then there's going to be at least two collisions. One where they stick together, one where one elastic and one inelastic collision. One where they bounce apart, elastic, one where they stick together, inelastic. Okay? So, is this one elastic or inelastic?
Inelastic.
What are some other examples? Well, instead of having two people running towards each other, I could have an arrow sticking into a target. That's actually easier because the target's initial velocity is 0, so you have one less momentum to deal with, and then they stick together and move off. Or a bullet hitting a target. I could have the target moving if someone was firing a bullet at something that was moving. They stick together. Okay, anyways. How would I handle this? First thing I would probably do is be lazy but organized. Mass A, mass B. Then I see north and south. I would probably say north is going to be positive, south is going to be negative. Now I think I'm ready to go. This is a collision, so I could say the sum of all the momentum initial equals the sum of all the final momentum. I won't be fussy if you didn't write that, but I know where I'm going now. Before the collision, I guess I have mass A, velocity A initial, and mass B, velocity B final. Is that right? Wham! They collide. After the collision, they stick together. How do I show stuck together? I say, I treat it like one mass in brackets, stuck together. Yep. I put final there. Now, the nice thing is, I would have caught that probably, but that's a good point. Thank you, sloppy mistake. Candy for you. Remind me to give you a candy. And I said, I think I'm going to try and find that. So I'll divide the bracket over. This is going to drop down. This is going to drop down like a domino. And I guess I would divide by the bracket. And if you don't mind, I'm going to put the VF right there by itself. Now I need to plug in numbers. Let's see. VF is going to be, what was mass A? It's going to be 82 and 7.5. Mass B, 65. And negative 8.1. This was a tricky question because, Alisher, I didn't have a good gut instinct at who's going to win this collision. Heavier person running slower, lighter person running faster. The difference in mass is a bit bigger than the difference in speed, so I suspect person A is going to win. I think we're going to get a positive north answer. Sorry, don't write M, Mr. Duick. 82 plus 65. But I have no idea what the answer is. I suspect because these are close, you probably got a fairly small velocity. I'm guessing under 1 meter per second, probably. 82 times 7.5. Oh, no, don't close off the bracket, Mr. Duick. Plus 65 times negative 8.1. Close off the top. Divided by 82 plus 65. Close off the bottom. You get 6.02. 0.602. I would take 0.6, but I'll go to 3 sig figs. 0.602 meters per second. It did want a direction. I got a positive answer. So what direction is that for me? You could write just an N. I'll write the word north. If you got that, I would give you, what was this question out of? 3 out of 3. Otherwise, I would give you a half mark if I saw that. A half mark if I saw that, a half mark for getting the V by itself, a half mark for doing that, and then a half mark for the magnitude and a half mark for the direction. There's my 3 marks. Is that all right? Number 2. Duick, nice try. 0.052 kilograms. This is asking me to find impulse. Because of that, Nick, I didn't bother labeling a mass A or a mass. There's only one mass. So I got a bit lazy that way. Everybody should have twigged on the word rebounds. I'm going to let one way be positive and one way be negative. there will be a question where something rebounds, but it might not be an up and down. It could also be like the thought puzzle we did, where it's moving sideways and it bounces off. Regardless, if it bounces off, if it changes direction, you need to let one way be positive and one way be negative. Make sure you're paying very close attention for those. It wants the impulse on the ball. Well, impulse is change in momentum. I can write that down. Now, there's three ways to find this. Change in anything is final minus initial. If they had given me the final momentum in kilogram meters per second and the initial momentum in kilogram meters per second, I would just do that. Did they? No. In fact, I said, you know what? They gave me a VF and a VI. I'm going to use M. The way I wrote it on your formula sheet is like that, but what's change in anything according to your formula sheet? What's change in anything according to your formula sheet? What's change in anything according to your formula sheet? No, look at the top left corner of your formula sheet. What's change in anything? So that's why this becomes MV final minus MV initial. You could also write it like this. The only reason I don't teach it that way, Alisher, is, believe it or not, I've counted up the number of keystrokes. This is one less calculator keystroke than that one. And yes, I'm that lazy. I have counted strokes. So it's going to be M.052, V final 6.2, minus M.052, V initial negative 8.2. 0.052 times 6.2 minus 0.052 times negative 8.2. Did y'all get 0.749? 0.7488, I would take that, but that's going to be 0.749. I guess it's going to be kilogram meters per second. It did ask for a direction. Direction. How do I know? That's what I let be positive. Up. If you got that, I would give you 2 out of 2. Otherwise, I would give you a half mark if I saw that, a half mark for that, a half mark for the magnitude, and a half mark for the direction. If you missed the change in direction, that down had to be negative. If you foolishly missed that and got negative 0.104, or if you said positive 0.104, I would give you 1 out of 2, and I would give you the frowning of a lifetime. Average force. Again, I have no problem if you go F equals ma, but I'm going to use the idea that impulse is also force times time. In fact, I would have jumped straight to saying force is impulse divided by time. It's 0.7488 divided by, where's time? 0.15. 0.7488 divided by 0.15. Did you get 4.99 newtons? No, yes? It wanted a direction. Which way? Also up, positive, yep. I would give you a half mark if I saw that, a half mark for that, a half mark for the magnitude, and a half mark for the direction. And then I would turn the page. And again, if you got the right answer using F equals ma, I'd give you full credit. Number 3, again, I see a final initial velocity, a final velocity. I see a time. I can find A, and I can go F equals ma, or I can use the impulse equation. The impulse equation says this: force times time also equals mv final minus mv initial. How would I get the F by itself? By the way, what if I gave you the force and said find time? How would I get the T by itself? Divided by F. So this is a nice equation because it contains so much stuff. So I'm going to go like that. I'm going to get I did a quick check. I don't see any changes in direction. I don't need to let one way be positive and one way be negative. If I saw words like backwards and forwards, I'd be way more paranoid. It's going to be 1200 V final minus 1200 V initial divided by 8. Do you get 1950? Yeah. Direction. Oh, no, they just said find the magnitude. They didn't care about direction, so who cares? I guess I would go something like this. I would probably give you 1 mark if I saw that, a half mark for that, and a half mark for the answer. My 5s get messier all the time. Number 4. Ooh, change in velocity. I said, you know what? Force times time also equals m delta v. Lifted that right from the impulse equation. So I guess the change in velocity is going to be the force times the time divided by the mass. I'm not going to panic. I can figure this out. The delta V is going to be the force, 120, time, 8, divided by the mass. I should go do that in my head, Mr. Dewick. It's going to be 120 divided by 5. That's 24. And they didn't say anything about a direction, so I'm good. I would probably go half mark for that. Half mark for that, half mark for that, and a half mark for the answer. Hockey. Collision. Okay. You know what? I'm going to use G for George, and I'm going to use J for Jim. Why not? I'll let east be positive, so that's positive. West is negative. That's negative. East is positive. This is a collision where they did not stick together, but this is a job for conservation of momentum. The sum of all the initial momentum equals the sum of all the final momentum. Before the collision, I guess I have mass George, velocity George, initial, mass Jim, velocity Jim, initial. Wham, they collide. They don't stick together. Mass George, velocity George, final. And mass Jim, velocity Jim, final. What am I trying to find? Looks like I'm trying to find Jim's final velocity. Daniel, the left-hand side is going to drop down like a domino. Then I guess I would minus mass George, velocity George, final, and I think I would divide by the mass of Jim. That's going to be the final velocity of Jim. So, we plug in numbers. I've scrolled down. Jet, what was George's mass? What was George's initial velocity? Jim's mass? Jim's initial velocity? That can't be right. Oh, first one was 12? Okay. So what's Jim's velocity? That can't be right. Oh, yeah. Minus 65. What was George's final velocity? Also 4? But positive? Or negative. Okay. All over 85. Get 2.12? Positive or negative? I got a positive answer. So 2.12 meters per second. What did I let? I let east be positive. Oh no, that works. No. Does that work? No. The answer is right. Here's the problem. This is impossible. George came in this way, Jim came in this way, and they hit each other. After the collision, which way was Jim traveling, magnitude and direction? This way. How fast? How fast is George traveling after the collision? The only way that works is if George somehow went through Jim. I made up some bad numbers. I was worried that I'd done that. Right? Think about it. If after the collision, George can't be in front of Jim somehow unless he's gone through him. But if George is going at 4 and Jim's only going at 2.12, George has gone through Jim somehow. I made up bad numbers. Sorry about that. But you're fine. If you got that 3 out of 3, otherwise, again, I would probably give you half mark for that, half mark for that, half mark for that, half mark for that, half mark for the magnitude, and a half mark for the direction. I'm going to give you all a really blatant hint. Listen, 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 listen. You know what a good part B would be? To ask you to calculate George's impulse. Or Jim's impulse. Both of them would be MV final minus MV initial. Just make sure you use the right masses and the right V's. Okay? Can you give yourself a lovely score, please, out of 14?